There we go. Hello, everyone. I'm Judy Black. I'm president of the RASC Halifax Center. So I welcome you this afternoon. For some of the world, it might be sunny. It's trying to get there here today, but I don't know how successful we'll be. For those new to our center, our meetings are recorded and they'll be available up on our RASC YouTube site within a couple of days, so that if you have to step out for any reason during part of this, you can certainly view the whole meeting again, or parts of it you'd like to review later on our RASC Halifax YouTube site. If you have questions during this webinar, because this is the first time in a long time we've actually held a webinar versus an actual meeting format. For those unfamiliar with webinar, if you just move your mouse or cursor down to the bottom of your viewing screen for this session, you'll see either the chat, you'll see chat, and you'll also see a Q&A. Put your questions in the Q&A and we will ask them on your behalf. And if you haven't already muted your microphone, please do so, and that way only the speaker in your sound won't interfere with ours. So for guests who are attending today who aren't members of RASC, we strongly encourage you to become one. There are several perks to becoming a member of RASC, and that's through the national office. First and foremost, you get this wonderful edition of the Observer's Handbook. This is the current edition. We have 10 contributors from our center in this wonderful production, and they have actually contributed 36 out of the 109 articles in here. So we have a significant number of people that contribute from this center. Also, you get your free edition of the Explore the Universe. This is the second edition.
Wow.
And so that will come to you as part of your membership. Not part of your membership, but certainly you can purchase, is the workbook that goes along with that particular program. And I'm sure Dave will talk more about the Explore the Universe in his program. Along with that, all these wonderful things you get. Subscription to Sky News. That comes out every second month or so. Wonderful articles from across Canada. And as Chris mentioned, of course, those of you that were in early, you'll see Chris as contributor to, Chris Gainor as a contributor to this edition. And in fact, I do believe Dave Chapman is in this one. If memory serves me correctly, yes. So our very own Dave Chapman is in this edition. Also, as well, you get our science journal, which comes out 6 times a year. So all these perks for joining the National RASC. Now from us here at Halifax, you get a couple of things. Certainly you get access to our very own newsletter called Nova Notes. And thanks to John McPhee and Lisa Ann Fanning, who refers to herself as being from the Halifax South chapter of our center. They put together a phenomenal newsletter. This one's 20 pages long. There's all sorts of articles, Gegenschein, New Star shines briefly in Cassiopeia, all sorts of neat, wonderful stuff. How I got started photographing the Milky Way. So there's all sorts of neat stuff in there as well. You also get access, when we meet in person, you have access to our library, and certainly access as well to the observatory that our center operates. So all sorts of reasons to become a member. But first and foremost, above all of this, the most incredible thing about RASC are the incredible people that you get to meet and know in this organization. One of the reasons that I became a member was because of the friendliness, the willingness to share, and the camaraderie among amateur and professional astronomers. No one is afraid or hanging on to the information that they know is being mined. They're very, very willing to share. And so you have access to that incredible knowledge all across the country. And so that's one of the greatest perks of all of this organization. Before we go any further, I'd like to wish happy birthday to anyone that's celebrating today or is celebrating until we meet next on June the 5th. Congratulations on another successful circumnavigation of the sun, and may we all continue to enjoy the next year coming up. So I'm going to share my screen for a moment. Oops. Where'd it go? There it is. All right. So welcome everyone to members and guests in attendance. I would like to let everyone know that RASC Halifax Center believes and follows the RASC policy regarding inclusivity and diversity. All are welcomed regardless of age, disability, gender reassignment, marriage and civil partnership, pregnancy and maternity, race, ethnic origin, color, nationality, national origin, religion or belief, or sex and sexual orientation. And we are opposed to all forms of unlawful and unfair discrimination. We'd also like to acknowledge our Indigenous lands. RASC Halifax Center would like to begin by acknowledging that we are in Mi'kma'ki, the ancestral and unceded territory of the Mi'kmaq people. This territory is covered by the treaties of peace and friendship, which Mi'kmaq and Maliseet peoples first signed with the British Crown in 1725. The treaties did not deal with surrender of lands and resources, but in fact recognized Mi'kmaq and Maliseet title and established the rules for what was to be an ongoing relationship between nations. Our agenda for today, following this introduction, our past president and photo montage collector, Paul Gray, will present the photos and sketches that he's collected over, I guess it's the last couple of months, given we didn't get one last month. We have special guests today with us, Chris Gainor from Victoria Centre, along with his two friends, George Lewycky and Jim Sakowski, who will address the amateur use of the Hubble Space Telescope, which we're really excited to listen and waiting very much so for this presentation. And as well, our very own Tony Schellinck will prepare or give us the basics of lunar sketching. It's those of us that are new to this will certainly be able to learn from Tony and what he's going to tell us there. Food for the soul, Paul will give his poem on Namesake Eye is the name of his poem, I do believe. Last month, we implemented a members' question period, and we're hoping to do so again this month. No one presented questions to us, so we're going to give a little bit of time where perhaps members, if they thought of a question they would like to put through on the Q&A, we will certainly try and answer the questions. And that was questions about any aspect of astronomy or the center or RASC itself. Dave Chapman, our observing chair, will give us what's up in the May skies, and then I will close with the news from the board. Following that, those of you guests and members who would like to stay with us for the Astro Chat, please hang in there. Jerry and I will, for those of you that aren't already panelists and wish to stay, we will lift your status from participant to panelists. That way we can see each other and all chat just like we normally do in our regular meetings. So without further ado, I'm going to stop sharing here. And Paul Gray, I'm going to give the floor to you so that you can then give us our photo montage, if you would, please.
All right, see if I can make this work. Slideshow. Oh, darn. It's on the wrong screen. Hold on.
I think when everybody figures out how to use Zoom, that'll be the time the pandemic actually ends.
Yeah.
I got two screens going. Are you seeing the slideshow or my screen?
The slideshow.
Excellent. That's what it's supposed to be. All right. Yeah, like Judy said, I wasn't here last month. I was in the middle of a renovation, which is almost finished now with the bathroom. So I was busy doing a window during the meeting. I had to do my work when friends were available to help me. But we have a bunch of photos this month and from last month, mostly lunar stuff from last month. And we're going to do a little different this time around. I'm actually going to cycle through everything that was sent to the email list from.
Okay.
Yep.
All right, I just got a message from Dave Lane. Sorry, they're not seeing the PowerPoint.
All right, we can change it up.
Have you pressed from beginning?
Yep. Bear with me. I'm gonna put everything back on my primary screen. Stop that. Back to that. From beginning. That's up. Back to Zoom. And we will go share screen and PowerPoint slideshow share.
There we go.
Now, does everybody else see it or just the panelists?
I'm good.
All right. So yeah, I'll just let it run through here. Every slide's 10 or 12 seconds. And once it goes, of course I'm in Zoom. There we go. So yeah, like I was saying, I'm actually I put everything not in order by date this time, but actually everything's in order by distance, starting from the outside in. So we're going out to the deep space with galaxies, and we're going to work our way into the moon, basically. It's like I said, we had a weird string of weather last month. When the moon was up, it was really clear, so a lot of people were sketching and imaging the moon. And then we had very little clear skies during the dark periods of the moon, so we didn't have a lot of stuff happening with deep sky imaging, or at least I didn't see a lot come through on the mailing list. So, and this does not seem to be advancing.
No, it's not.
That's weird. Anyway, I will click through it. So yeah, Jerry did a couple shots, or a nice shot of M81, M82. I did one of M81. This was actually back in very early March, before things got dark. Now it's advancing. Working our way in, Globular Clusters, Messier 4 by David Hoskin. David, I think, has been the most busy of all of the imagers in the club. He's been imaging pretty much any clear night or day he could get out and get the sun or the moon or the deep sky objects. Jerry, of course, has been out a couple times. I think this was done at St. Croix. Jerry, Judy, and there's a crowd of yous down there one night last month. There was a fairly, I wouldn't say bright, but decently bright visible nova in Cassiopeia last month. I believe it peaked around 8th magnitude, so it was something that you could image or visually find with a scope. Working our way in, we're coming into the moon. Actually, I got this out of sequence. The sun was supposed to be next, so I missed the one. But Charles White's been doing some great sketches as usual. Just rather than just show the sketch, I put his whole notes up there for people to take a quick scan of what he's using and what he's done. It's some nice work. David Hoskins, again, the sun. He's got some amazing stuff. David, you've been doing some great stuff. The full disk of the sunspots, I know the last week and a half, there's been a lot of spots. 30, 40, 50 was the sunspot count.
Wow, that's a nice one.
David's been doing some nice stuff in H alpha. It gets even better here. He gets some nice close-up shots in a minute, but some nice prominences there, some nice surface detail in the sun. Beautiful shot there of a couple good sunspots with all the faculae and other details around them and features. I must say, putting this together this week for the last 2 months, there's a real wide range of decent images. Not so much the deep sky that we used to have. I mean, there was a few there, but to see that so many of us doing lunar work and solar work, it was really nice to see us taking advantage of the weather we can get. That's a lovely shot. I like that. That was really well done. I don't have all the details for every image. I just didn't have the time to add everything in. I'm trying to do that more now. And I think that's one of my favorites from David this month. That's a beautiful shot. Lots going on there. Jerry Block, I believe this was that nice dark night down in St. Croix. The young crescent moon is right where my cursor is, if you can see my cursor on the screen or not. Pretty much straight above the top of the mount. And Judy, you did this was your camera on your phone, I believe?
Yes, it was.
Rupes Recta, the straight wall. I think there was a dozen of us that went out that night and tried shooting that.
Wow.
Not Charles, Mike Gatto. Oh, Michael's sketches are just something to drop your jaw for. I copied his details and posted them here. I hope it's on long enough. I think I made it 15 seconds so you can read through what he's done and what he was seeing. Phenomenal work again. It's one thing to watch him do his sketches, but even just seeing his final results is just mind-boggling. My son was looking at it this early. He goes, "That's a sketch. That's not a picture." Like, he was blown away by the fact that these are pencil.
No.
I love that. That's a great shot.
It's like a Stonehenge.
A lot of detail in there. Oh, Michael's online or not, but if you are, Michael, great work. I want to talk to you about some calendar shots. I really like that one too, but I want to invert it 180 degrees for some reason. I don't know why. I just feel like it. In images, there's a few of us that did a lot of images of the moon in the past months. Baby and Pittman did a series of shots here, and I'm going to keep everybody's together as groups this time so that we can see what they did all at once. But that was a great shot, and then he highlighted on this one the V, the X, and the L that was all visible on the one just before quarter moon phase there. And again, there was a few of us that went out and shot all these, but really nice to see that. And then he sent some close-ups of each area too.
Nice capture of the Hyginus rill too.
Yeah, I see the rills in there. I couldn't think of the name of it. Thank you, Judy. If you know any names of any of these, because I didn't have everybody's details, so if you know the names of any of these that popped out at you.
There's the X.
Yeah, there's the X. Like I said, there was a bunch of us that had a great view of it here on the East Coast back in March. We had a great run. And up the other end of the moon.
Altai-Scarp there, the bright wall on sort of bottom middle. Just
Yeah. Full light though, right?
Yeah.
I took advantage of 4 nights in a row and got out as well. Mainly went out for the X the first night, but and of course Rupa's Recta was up as well, so I made my crack at that. What I really enjoyed doing, and what I'll show in the next series of shots, was I was able to visit some craters or some seas and go back the next night or the night later. So see them at sunrise and then see them a day or two later under different sunlight. And it was not often we get a run of nights in a row where you can do that. So it was really neat. I'm quite pleased because the detail you can get on different parts of the moon when you just go from 24 to 48 hours later.
Yeah.
Borealis, for example, during sunrise, you can see how steep the crater is and how the walls are. But then when you go to the next day, Borealis is up here. It's a different scale I was using, but again, under full daylight, you can see the central peak and the terraces inside.
Wow.
And then same with Clavius. I got to go to Clavius one night and come back a couple nights later. The seeing wasn't as good, so I had to use the smaller scale zoom factor, but pretty darn nice. I was quite happy to just see the changes with the sun rising. And then Copernicus. And again, 48 hours later. And actually, there's one of these I went down looking. I forget where it's at. I think it's down in this region, around here somewhere. I've actually been able to locate some of the lava domes as well. They're very hard to pick out, but when you zoom in on the full res image, you can see lava domes. So the seeing was pretty decent. So yeah, that's images from the last month and a half by a number of us that were all posted to the email group. Again, I didn't pull anything off the Facebook group, and I didn't go searching for anything. So if it's not in my inbox, I don't really find the time to go looking and add stuff in. But if anybody else out there wants to, just remember, mail it to the list, and I'm probably going to include it. So that's images for the month. Judy, if you don't mind, I got 5 minutes.
Yes, please.
Yes. I mentioned
And
to Judy.
before you begin though, Paul,
Okay.
Dave made a comment that we're becoming a center of lunatics.
But that's good. We're using the clear skies when we get them.
That's correct.
That's the important thing. I mean, there's some great lunar programs in the society, from the beginners ones to the Isabel Williamson, and I love seeing the interest out there. I don't know if I could visually do it, but I'm starting to think now that I'm going to try and image all the features in it. Just create a catalog of images of them. I don't know if I'll ever submit it or if you can submit that or what. It's been so long since I've been doing anything, but I'm working on 5 different programs right now that I haven't done much imaging or program work visually or imaging in the last few years. I've just been so busy with everything else. So this winter and spring, I've been kind of hopscotching around 5 different programs. So it's keeping me busy in my off time when we get clear skies. The other thing I've been doing, and this is what I asked you to give me a little bit of extra time for, was dealing with light pollution. I would ask for a raise of hands, but I can't see everybody's windows on the screen. I don't know, but maybe in the chat, it'd be interesting to know how many people have actually gone about updating, replacing, or purchasing lights for their house outside that are dark sky compliant. It'd be neat. I'd just be curious to know how many of us are actually, as astronomers, have lights in our house that are friendly to the skies.
We had them on the apartment building for a year and a half, and then the insurance company reevaluated the building and put floodlights on the whole outside of the building and told the landlord if he didn't leave the floodlights on 24/7, he would have no insurance. It's absurd. And we went 8 years with full cutoffs, shielded lights. It was great. But now we're back to, I don't need to turn the lights on at night in my apartment.
Yeah. But no, I guess from homeowners' point of view, though, Paul, like for people who own their own place, the only excuse for not doing it is simply just not doing it. And I wanted to show you an example. This is actually taken from my backyard, just outside my observatory, looking up at the backside of my house. If I was to turn around in this picture, the wash from the glare that's coming out of my carport, it's not coming directly on my observatory because the light is actually around the corner here, mounted on the wall by the door. But I could actually see my shadow on my observatory wall lightly at night if the carport lights were on. Now the kitchen light is up here above the deck, and my daughter's room is down here with blackout blinds, so that's not a problem. But you can see there's quite a bit of scatter of light to the side and down the backyard. In the next image, I'm actually going to take about 10 steps to the right, so you can see the car lights or the lights in my carport directly. And of course, the orange yellow is a high pressure sodium light across the street in my neighbor's place. It's actually in the woods about 50, 60 feet. And come summertime, all these trees are fully leafed. I don't see that light at all, but that light, this picture was actually taken back in December. A couple little patches of ice there, and that's it. But you can see the glare from these lights. I had 3 glare bombs, basically, old lantern styled lights that were in my carport. Each had I think it was an 11 watt or a 13 watt compact fluorescent bulb in it, popping out about 800 lumens each. And as you can tell, the shadows from my railings, everything down the yard, it's quite glaring. I mean, my daughter's room with the blackout blinds, you can barely see anything. And then through the back door of the kitchen, you can see lights inside. But well, the glare from these was just, it's been bugging me for about 5 years since I built the observatory, and I've never done nothing about it. So this winter, I did something about it. I went shopping and I actually found these guys. They're little exterior lights. They're pot lights, or a full cutoff recessed pot style light. They are closed in on the top. You can find a lot of them where they're open top and bottom, but you can actually find this particular brand, I believe, is at Home Depot. And then there's another brand at Kent that's the same style, but it's brushed silver instead of the brass, the dark brass. They can take up to a standard 60 watt incandescent bulb, or your 13 watt CFL. I did not put those in this. I actually went back. I went to an LED, but I put 3 of these in my carport, and this is what it looks like now, standing in my
Wow.
backyard. So you can see each individual light now instead of the glare. My daughter's room, the blinds are open in this case, but you can see into her room with the light. But you know, there's almost no light on the roof of the carport. There's really no sideways wash at all, and there's no wash down to the observatory. And to give you an idea what the carport looks like when you're standing in it, this is the pattern you get from them. I put I believe it is a 5 watt LED in each. Each one produces 450 lumens. I was thinking at first my wife wouldn't be happy that there wouldn't be enough light coming in from the cars at night from the driveway, but no complaints. Everybody's happy. Everybody's good. I can stand at the observatory now, and I do not see my shadow on the wall. I do not see any shadows at all. And the only shadow I was seeing was from my neighbors. I'm just going to give you a quick peek here. My neighbors had one of these on their back door over their deck, and one of them on their side door. And both of them shined into my yard as well. And I have a good relationship with my neighbors. We get along great. Everything's going really good. She's a teacher. He's a pilot at the Air Force here. So they're both understanding and have of the mind of interested in my observatory. They've both been over at some point in time and used it and stuff. And after I installed my new lights, Luke was over one night and we were talking and he was looking at it. He said, "Those are really sharp." I said, "Yeah." I said, "You noticed the shadows we're seeing?" I said, "Yeah." He said, "Yeah." I said, that's from your lights." I said, "The summertime, I don't worry about it. There's a maple tree in their backyard that's I can't put my arms around. It's probably about 3 feet across at the base of the trunk. And when it fills out with leaves, I don't see their lights at all from the house or anything. But in the wintertime and fall and spring, I do. So I actually asked them, I said, "You know, if you really like those lights, if you guys want it, I'd buy 2 to put on your house if you want to replace the ones you have, if you don't mind." And they actually just got posted. And I asked them, I said, "You know, if you really want those lights, I'll put them up for you." And he said, "Yeah." I said, "But you got to do it before Wednesday because that's when the listing goes online." So sure enough, I bought 2 lights and put them on the house for them. So now I don't have any shadows from my neighbor's house either. So probably wondering how much do they cost? They're $30 a piece, $29.99 plus tax, and they work great. So if anybody out there has a backyard or a side light and you find you're turning it off because you want to go out and use your telescope in your backyard, or if you want to be the good neighbor to the amphibians and the wetlands around you, and you want to put in full cutoff lights, there's no excuse not to. There are choices out there. There's fancier ones out there. But, you know, for $30 a pop, these guys are really cheap. They're really easy to put in, and they work like a charm. They're great. So that's my spiel. No excuse for us not to be doing it.
I think from the comments that we're receiving in the chat, Paul, that one of the things that RASC should probably be doing is going after the insurance companies regarding lighting and how much is truly required for insurance, because a couple of members in the chat have already cited that they are adjacent to commercial entities, and if they don't keep that bright lighting, they don't get insurance.
Yeah. Yeah, it's interesting with some commercial businesses and how things are operating. The big corporations seem to get it, and it's interesting. If you go around, I know a lot of the big companies, even the Canadian Tire, like here in Greenwood, the Canadian Tire and the Sobeys and the Walmart, a lot of the lights in those parking lots after a certain hour are actually shutting off now. They're not running them all night. It's they get the fact that the power bills cost and they don't need the light. You know, they need some, but not all. So there are some organizations that are getting it. It's slow getting through, and that's part of a whole light abatement thing from I guess from an organizational point of view. Yeah. My whole idea of this spiel was from a personal point of view, what we should all be doing ourselves.
Yeah.
So.
And Susan Holmes comments, darkness helps birds too.
Well, it does. It's great. Plus, you know, when I
And
go
plants, everything. Yeah.
I'm waiting for next month because I really want to go out in my carport this spring and see whether or not there's June bugs in it or not. Because the light attracts the June bugs. And if I don't have those lights on, or if I just have a little bit of light, it might not be as bad.
we'll wait to hear your peer-reviewed science project.
I might have to put yellow amber ones in for that, though. That's a whole other talk. Thank you very much.
Okay, thanks so much, Paul. That's great. So if just something to think about if you are in the business of thinking about changing your outdoor lights, something to look at. And I'm sure there are guidelines as well on the RASC website if anyone is interested, and in the OH for Roy Bishop's purposes. Next up is our guest speaker, Chris Gainor. I met Chris, I guess, at my very first GA in 2015 or so. And Chris is a past president of the National RASC. He's also an author of 6 books, and his most recent one, Not Yet Imagined, a study of Hubble Space Telescope operations, is downloadable off the RASC website, and it's going to be in hardcover out soon. I'm sure he'll tell you more about that. He's also editor of Quest, the History of Spaceflight Quarterly. And today he's going to talk about the amateur use of the Hubble Space Telescope, and with him, he has 2 amateur astronomers. And so I will let Chris introduce them throughout his talk. So Chris, welcome, and we're truly looking forward to your presentation.
It's good to be here. Greetings from the West Coast. It's also sunny over here today, I guess I'm in Victoria, which of course is the home of Canada's Pacific Fleet, and Halifax is the home of the Atlantic Fleet. So we have that in common, amongst other things. But yes, this talk kind of came together in an interesting fashion. I've been working on this book about Hubble for NASA the last few years, and there's a short section in it, a couple of pages in there about the story of the amateurs who got to use Hubble. And I decided the book was completed, and it came out in electronic form in January. I hope the printed version will be out very soon. But amongst several projects I had, in which I had more time for because of the pandemic, I wanted to expand that section about the amateurs and write up an article for the Journal of the RASC, which Judy showed you a copy of a little while ago. So I was working on this early this year, but hadn't really told anybody I was doing this. And then one day I heard from Judy, and she said, "Do you want to talk about the amateurs who worked on Hubble?" And I had, usually when I talk to RASC groups, I do mention the amateurs as part of the general talk I do about Hubble. But I decided I was busy writing my article for JRASC, which is going to be in the June issue, coming out very soon. But I was also developing a presentation that focused on that. So anyway, I got this invitation. I thought, well, why don't we take advantage of the situation we have now and get a couple of those people who actually got to use it into the talk, so you could hear it firsthand rather than through the through my interpretation. So I'm going to give my talk, and then we're going to there's a couple of spots where we'll be hearing from our guest today. Jim Sakowski is here, and he was the first amateur astronomer to use Hubble back in 1992. And then we have George Lewycky here as well. And he was one of the amateurs in the second round who made an observation. Actually, I think Jim also was involved in the second round as well. So and if my memory serves me right, you guys are both from New Jersey, right?
No, I'm from New Jersey.
Okay. And anyway, Eastern Seaboard. So I'm just going to start into it now. Just sort of a few basics about Hubble, and this bears on the topic because of course observing on Hubble is quite different from dragging your scope into your backyard and looking up. It's quite a different thing. Of course, the main reason for Hubble is that you can see all sorts of different wavelengths. Now, this slide actually shows wavelengths that can be seen by other telescopes, the so-called great observatories. To the right of Hubble there, you can see the Spitzer Space Telescope, and it will be observing in the infrared. Hubble observes mainly in the visible, the near ultraviolet, and the near infrared, just sort of that narrow band there. But even that is much more than we can see from here on the ground, and that will always be the case even when we get adaptive optics. That's the other part of the piece, of course, is that when you're observing from space, you don't ever have to worry about weather or turbulence in the atmosphere or anything like that. And you can see a couple of other of the great observatories, the Chandra X-ray Telescope and the Compton Gamma Ray Telescope. And of course, later this year, hopefully, we're going to have the James Webb Space Telescope, which will be observing in the infrared. But Hubble has unique capability, and when it stops observing, whenever that is, we'll be losing that capability probably for a number of years before a future telescope kind of fills in that role. And I just wanted to mention that before Hubble was launched in 1990, there were amateurs who were thinking about, why don't we have our own amateur space telescope? And there's a group of people at the Rensselaer Polytechnic Institute in the state of New York, I think Troy, New York, who actually came up with this idea that you see here in 1979. And it was going to have a 45 centimeter Ritchie-Chrétien telescope in it. And that proposal was around for 3 or 4 years, but it actually never happened, probably because of expense and complication. But what happened is that Hubble was launched in 1990, and this is just a schematic of Hubble. It's, we call it a space telescope, but it's probably more accurate to call it an observatory because it has a number of different instruments in it. You can see, I don't know if you see my cursor, but right at the bottom of the telescope there, you can see the axial instruments. There's 4 of them. They kind of look and they're about the same size as phone booths. And just above them are radial instruments, and most of them, there's 4 of them now. 3 of them are star trackers, which actually act as fine guidance sensors. I'm sorry, which also act as an instrument in their own right. But the fourth one is a camera, and Hubble is a 2.4 meter Ritchie-Chrétien. The mirror is over here just above the instruments. So the light comes in, bounces back to the secondary, and then is sent down into the instruments. So when you want to make an observation on Hubble, you have to figure out which instrument you want to use, and you can go and download the manuals for using those instruments. If you printed out those manuals, it'd be something like a phone book, I think. It's fairly complicated. And as you can see, Hubble is powered by solar panels, and it's about as large as a school bus. So over its history, Hubble has had a number of different instruments. So it's changed over time. The instruments that are on board Hubble now, which are changed out by shuttle crews in their servicing missions, are actually quite different from the ones that were there when Hubble was launched, and the ones that Jim and George used. Today they're much more powerful, and you can see you have imaging instruments and spectroscopy, and then a couple of different instruments as well. And I have pictures of the instruments when they're not inside Hubble, so give you an idea of how big they are. The one at the bottom, of course, is taken during a servicing mission. So, and the story of the evolution of these instruments is, of course, told in some detail in my book. And then Hubble, of course, is more than just a telescope. There's a whole infrastructure for it. Data goes up and down from Hubble through the TDRS satellites. You can see one there. And then it goes to the Goddard Space Flight Center in the suburbs of Washington, D.C., which is the main control center for NASA's scientific satellites. But the scientific data is all processed at the Space Telescope Science Institute, which is about half an hour, depending on the traffic, drive from Goddard. It's at Johns Hopkins University in Baltimore. And I believe just about now, the Space Telescope Science Institute is celebrating its 40th anniversary. It was basically set up to allow for scientific oversight of the work of Hubble. There's a bit of politics there. That's all in my book. I won't get into it today. And that will also be the place where the James Webb Space Telescope is controlled, and the scientific work is done there. And I think, and we'll be talking a bit more about STSCI as we go on in this talk. So Hubble was supposed to be launched in the mid-'80s, but as we know, for a variety of reasons, including the loss of the Challenger space shuttle, it wasn't launched until 1990. But the first the first director of the Institute was an amazing fellow who we see here, Ricardo Giaconi, who actually won the Nobel Prize for his work as an X-ray astronomer. And at first he wasn't a big fan of Hubble, but he was talked into becoming director of the Space Telescope Science Institute, which he did for 11 or 12 years. And he was quite successful in that job. There was some tension between NASA and the Institute at that time, because NASA was kind of accustomed to running everything directly, and Giaconi was fondly remembered for standing up for the interests of the astronomers and physicists. Now, while working in a previous X-ray satellite program, Giaconi had gotten some help from some amateurs who did some observations, of course, in optical wavelengths of X-ray sources. And he also thought that amateur astronomers in the United States were amongst those many people who paid a lot of taxes to help get Hubble up in the air, or up above the air, that is. And so he thought it would be a good idea if some time was given to amateur astronomers. Now, most of the time on Hubble is observing time is given out through a peer-reviewed process, which has become kind of standard in observatories in space and on the ground. But the director of the Institute has what's called director's discretionary time, which is, I think, amounts to about 10% of the time on Hubble. So he can do with it whatever he wants. And so far it's been a he. We actually had an interim director who was a woman, and hopefully we'll have a woman director one of these days. But anyway, of course, the director will take flack if the professional astronomers don't like how he uses the time. But that has turned out to be a very good feature. For example, the Hubble Deep Field was a product of that, but that's another story. But anyway, early on in the piece, Dr. Giaconi decided that it would be a good idea if he gave a small portion of his discretionary time to amateur astronomers. So so in 1985, he invited the directors of amateur astronomy organizations in the United States to form a working group and on amateur astronomers, and so that was formed. And I believe in 1986 he announced this at a meeting of the Astronomical League, and of course word got around. Now, this was restricted to amateur astronomers in the United States, but amongst other things, this guide that you see in the slide was produced and sent out to people. Now, by the time that went out, we'd had the Challenger explosion, so there were a number of delays. But the plan was always to make that available to amateurs early on in the piece. So finally, after all the delays, Hubble was launched 31 years ago now, on April 24th, 1990, on Discovery. And the next day it was deployed into space. Now, all these delays were actually a good thing for Hubble anyway. The silver lining to that terribly dark cloud, because if it had been launched in 1986, I think there would have had a lot more problems than it ultimately did have, and perhaps even fatal problems. One of the big ones was the solar panels. They actually changed out the solar panels during that delay, and even those ones had their problems. But anyway, it was launched, and everybody was looking forward to using it. Well, I think most of us are old enough to remember what happened. It was discovered that Hubble's mirror was precisely grounded to the wrong shape. And now, even with that defect, even with its spherical aberration, it was still better than anything on the ground, but it was a problem. And so NASA went to work developing a plan to deal with that. Now that plan was implemented with the first servicing mission, which took place at the end of 1993. They replaced the main camera on Hubble with one fitted with kind of an extra set of mirrors that compensated for the spherical aberration and cleared up its vision. And then one of the original instruments was taken out, the high-speed photometer, and replaced with something called CoStar, which put a set of mirrors into the light path and was able to clear up the spherical aberration for the other instruments. But that was still 3 or 4 years ahead, and Hubble late in 1990 started making observations. Now, by that time, Dr. Giaconi had, even before Hubble was launched, Dr. Giaconi had announced that time on Hubble had been given to 5 amateur astronomers, and this was out of about 200 entries that had been received from amateur astronomers, and there are about 500 people involved in those proposals. And so finally, in 1992, a fellow named Jim Sakowski, who you see here in the pages of Sky and Telescope, made the very first observation by amateurs on Hubble. And I'm pleased to say that Jim is here with us, and I'm just going to ask him in a moment to tell us what happened. Because of the spherical aberration, I understand that it did degrade a couple of those observations from the amateurs. And there's one of the 5 scheduled observations was actually canceled and never took place. And that was by a woman named Anna Larson. Who it's a fascinating case. I think she wanted to make observations of T Tauri stars, and you needed the full OOP of Hubble, and which you wouldn't get with spherical aberration. So they canceled the observation. And as Jim and George will probably be telling us, everybody got to visit the Space Telescope Institute, including Ms. Larson. And she was so inspired by that experience that after she got home, she decided, I'm going to go to graduate school. And so she did. She actually, she's from Washington State, but she came up here to Victoria and got her PhD in astronomy at the University of Victoria, which is just up the road from me. And she's now an instructor at the University of Washington. So that's a fabulous story. But now I'm going to hand it over to Jim, and he can tell us what happened back in 1992.
Yeah, hi. This is thank you for having me here. It's kind of emotional for me. To hear all these things and the history of this, and yeah, that picture brings back a lot of memories. I was so excited when that picture was taken. That was taken when my observations came in, and unlike you guys, I don't do pictures with telescopes. I never have. I just read an enormous amount of stuff about astronomy, and my first telescope only cost $20. And we were a poor family, and so to jump from a $20 telescope to something like this is unbelievable for me. And I was really excited about doing this. I wanted so bad to do this. I think I sent 10 proposals in, and then 3 of them went to the second round. And so I had it all written up for 3 of them, and as it was, 2 of them got accepted. And this one was the first one. It involved post-eclipse brightening of Io. So when Io goes behind Jupiter, the atmosphere freezes out. It's sulfur dioxide all freezes out. And then when it comes out of the shadow, it's brighter. It's brighter by 10%. And it was a mystery because sometimes people saw it and sometimes people didn't. And the Hubble hopefully would have been able to see it because it was when Io comes out, it's in the glare of Jupiter, and so it's very, very hard to measure that 10% difference in brightness. And Voyager should have seen it, but Voyager didn't see it. So it was when I did the observations, it was up in the air whether that happens or not. And so I did the observations, and they were not really affected by the spherical aberration. I was measuring mostly the light, the amount of light coming in. I wasn't after clear pictures, but I did get some neat pictures of Io, and I was able to compare those to what Voyager saw, and we did see some changes because all the volcanoes. So it was very exciting, and it was the middle of the night, and it's a time they left us come in for the observations. I don't know if George came in for his observations, but they left me come in for the observations to see him live. And after that, I don't know if they did that so much, but it was really exciting. Changed my life. And my second observation was with the spectroscope, and we were looking for outgassing from old comets. So there's an idea that many comets go around the sun a while, and then they get like a crust on them or so, and then they stop giving off gas and dust. And I was looking for a little bit more of that I was looking for water coming out, the OH radical coming out. It would have been easy to see. And again, we're looking for ultraviolet there, and we didn't see any. And that was an exciting possibility because I envisioned in my mind that if we found water in these different asteroids, we could use those for gas stations. So we go to these different asteroids and drill in there and get the water, get the ice, and then change the water into hydrogen and oxygen. Then we go on and explore the rest of the solar system. So that's what I envisioned, but it didn't work out. But it was all fun, and it was a big leap for me because I've never done the camera work with telescopes, and like I said, I'm just a science teacher, but I'm still teaching science. I guess I'm on Facebook, and after all these years, I still get questions from my students and their parents, the ones that are still alive. But it's been quite a journey here, and I like to encourage people to get involved in more amateur work. NASA has several programs where you could use their telescopes. I'm using a telescope that goes around Mars now, HiRISE, and you go through the process. You sign up and you suggest targets on Mars for them to take pictures of, and if they deem them important, after a few months, they'll take a picture of it. So I get all excited. In fact, a couple of days, I'll get my pictures from Mars, and I'm all excited. It's the biggest thing the whole month is to get my pictures from Mars, and some of them are really pretty, some of them are really nice, and I put them on my Facebook page, and I show them my friends. But it's exciting. It's all exciting, and it's so great to be able to do these things and right from home. So thanks for letting me talk about my experience. It was great.
Yes, and you're from New York State. I'm just correcting what I said earlier.
I lived in New York when I did this, and now I'm in Denver in Colorado.
Oh, okay. And would that be must be a better place to observe?
Well, I would think so, but I can't see anything. I can't see the sky at all here. I drive different places and I walk places, and I can't see often more than 20 stars. And I once went with the Boy Scouts. They went to do a big observatory night, and we went out and we drove for hours and hours in the middle of nowhere, and we still had the glow in the sky from Denver. And it was pretty much a third of the sky was affected, but we did see a lot of things. But so for me, I'd have to drive for hours to get to a nice place or whatever. So it's difficult in Colorado to see things, as in many places, I guess.
So yes, so the first round of observations were made in 1992, and that year there was a second round of astronomers. Let me see, and I'm just looking at my script here, and so this is these are the people who were selected in the second round, and both of our guests are here. Jim got selected there, and George, and you can see Dr. Giaconi there when everybody came to visit the institute. So now these are a couple of pictures that George took, and I'm going to hand the floor to George, and he can tell us about his experience at the institute. And of course, I get a kick out of those big monster monitors that really date things. And the picture, the one picture shows Dr. Giaconi, and also my very good friend Ray Villard, who is still at the institute. I met him around that time, and because he occasionally comes up here to give talks up in the West Coast, and so he became a friend and gave me a tour of the institute back in the 90s. And when I took that tour, I had no idea that would be playing a role in my future and that I would be back. But anyway, go ahead, George.
Thanks, Chris, and thanks for the invitation and everything, and for the well-written book too. I'm also a solar system kind of guy. I like things close to me. I mean, I had a few other ideas after I found out about the opportunity in Astronomy magazine. There was actually a little blurb in the magazine announcing this, and this is before the web and email and everything, so you had to to send them a letter, and then they sent you the package back going through it. And I had like 3 ideas, Beta Pictoris, the Oort cloud, which was kind of interesting to me. And then I stumbled onto this thing about Saturn's moon Titan that I remember from from the late 80s. Saturn's my favorite planet. I even have a tattoo of Saturn and Titan now. I got that for my 50th birthday. I'll be happy to show it to you if you want to see it. And so I saw this episode of Nova called Resolution on Saturn, and I had no idea back in 1981 that was going to change my life 10 years later. And I remember the scientist who was my inspiration, and I actually got to meet him at JPL, Toby Owen. And he actually worked with Carl Sagan and many others. So it was a I actually got in touch with Carl Sagan. That's another story. And but I remember him going over this one highlight of the spectra, of Saturn's moon Titan about the hydrogen cyanide. So that stuck in my head all those years. So, when I started doing research at my local library, you got to remember, we didn't have Google back then and all that stuff. And the web was just basically starting out, and public access was very minimal and very expensive. So I'm there doing some searches. I did a thing on hydrogen cyanide, and I found an article in the Science Journal. And the scientist over in the Netherlands, who I also got in touch with, and he did a laboratory experiment of hydrogen cyanide and formaldehyde. The stinky gas you remember from biology class. That you probably dissected your frogs and so forth in. Well, those 2 things changed my life. I found out that experiment, led to adenine, which is one of the 4 bases for DNA. So my question is, I have one part of the experiment, one part of the equation there is formaldehyde there. So I kind of like, that got me started, and I decided that I was going to stick with Titan, searching for formaldehyde. And for like 7 months, I was working on the proposal nonstop. And it was a heck of a learning curve. We had to learn the instruments and so forth. I had to find data on formaldehyde and the ultraviolet. I was at numerous libraries, in the tri-state area, and connecting with professionals and so forth. You're not going to believe where I got my formaldehyde data from. General Motors, of all people. It was just unbelievable, the whole experience. I got in touch with Toby Owen, who at that time was working in Hawaii, and he gave me some advice and reviewed my my proposal and so forth. And I got in touch with him after it got approved, and he was all ecstatic too. And so that was a real inspiration. And then when we got to go to the institute for our orientation and so forth, Ray Villard actually told me that Carl Sagan was doing a talk about Titan and water. So I tried writing to him, trying to, I'm not going to be able to make the meeting, and I tried to get a copy of that letter of his talk or whatever. But he wrote back to me. I actually have his autograph and everything, with some articles and so forth, and even notes and equations that he sent me, which was pretty mind-boggling too. And he was also big with Titan as well. And then I got in touch with that, but it was a heck of a learning curve. We were like celebrities, we were promoting the Hubble telescope, giving lectures, all over the country and so forth. And we still are. I still get contacted for Q&A and stuff. I even have a frequently asked questions on my website. People actually thought that we went up on on the space shuttle to use the telescope in space. You know, I mean, you know, all kinds of, you know, crazy questions that you couldn't imagine. And most recently, I've been, you know, I actually, when I was also at JPL to meet Toby Owen, they were working on the Huygens mission, the Cassini mission to Saturn, and the Huygens probe going to Titan. So I got to meet Toby Owen and many of the other scientists involved with that, which was a real thrill and experience over there as well, you know, before Cassini was still being built. And then I went down, I wanted to go to see the launch, but I couldn't make it, but I saw the shuttle launch of the first repair mission, which was a real thrill seeing that at night. And just recently, about 4 years ago, I was down at Goddard giving a lecture. They were having these experts, you know, specializing in Titan. And I made friends, I made a lot of friends, you know, nationwide with scientists that were very helpful and cooperative and giving me references and all kinds of stuff. And this one guy, you know, Gordy at Goddard, introduced me to another scientist who was, you know, working on these Titan workshops. So I got down there and actually did 2 posters recently. They're on my website too. You know, one on the scientific end of it, and one more about the experience of the whole shebang. And that was a real thrill too, and meeting other scientists and, you know, a lot of new young ones that are really getting into the Titan groove and everything. And I tell them my stories and stuff, and, you know, they can't believe it, you know, that I was actually in touch with the late Carl Sagan. And, you know, Toby Owen unfortunately passed away, I think last year. I was very upset. You know, I was hoping to see him again, but I found out that he had cancer, and one, you know, my friend Gordy, who works at Goddard, notified me. So, and as far as an update on the formaldehyde, my solar data, there's so much solar data that's reflected and absorbed in Titan's atmosphere. Titan acts like a mirror, like a mirror to the sun. So I had so much strong ultraviolet data that I needed data from the Solar Max mission, you know, from a scientist that I met and visited at Harvard. And the amount of solar data was so comparable to his data, you know, that, you know, I offered it to him as well, but it was so difficult to, you know, to narrow down the formaldehyde at its strongest absorption, because the sun is so strong in the ultraviolet over there. But recently I found out that, you know, they found formaldehyde on Titan in its atmosphere from the Cassini mission. So that was a real thrill to find out that it has been found, and now they're working on what's next over there.
So that photo at the right there, that's actually when your observations were being done at the Institute. Is that correct?
I was there for my observation too, and I was actually competing with, you know, they kept rescheduling us. I don't know about Jim, but God, it's like when I got a phone call from my tech assistant down there, I'm like, oh no, it got rescheduled again. I got rescheduled like 4 times. And then I'm down there, and I got bumped another day. And then, you know, I was competing with the space shuttle, who got bumped another day too. And we were fighting for use of the TDRS satellites, the tracking data relay satellites that, you know, they need for communications and data transfer. Well, the Hubble uses that as well. So while I'm there waiting a few hours for my data or whatever, you know, they're telling me that it's going to be delayed again because of the space shuttle. And, you know, it was kind of a funny experience. They had the speakerphone on, you know, from White Sands to Mexico, doing communications and stuff. And, you know, someone overheard me about the, you know, complaining about the shuttle, you know, holding up my data and everything. And it was funny, you know, and, you know, everybody was so cooperative. A lot of the professionals were very helpful to me. with my proposal and the data processing. I'm already a computer programmer, so the computer end of it, was a little bit helpful for me. But as far as the spectra and doing all that work, it was a heck of a learning curve. I couldn't even pronounce spectroscopy, and the librarians used to laugh when I said spectroscopy or something like that, so it was a real experience.
And part of the deal is that you had to publish your results.
Correct. Yeah, and right, like I said, right now I had 2 posters that were done at a science conference at Goddard,
Yeah,
and
and they're posted on your website.
they're posted on my website as well. Yeah.
Something that I was struck in, reading what you've said about this is the huge amount of work you had to do for your proposal, and that it was you had to do a huge amount of research, and both of you were working in the days before we had the internet.
Yeah.
So
and I had a full-time and I had a full-time job too. So it's like I was living at libraries in New York City and New Jersey. Luckily, I had some great libraries, and they do a lot of astronomy and stuff there too. And then I learned a lot of researching tricks. Some of the stuff by accident, like how the Library of Congress catalogs things and tricks like the call numbers on the books that they have when you go look for them, because it's like in that area, there's usually other books that are similar to that type of book. So I was able to discover and find, where the formaldehyde, is and so forth. Yeah, because you got to remember, I had to learn how to, the instrument. I had to do research on Titan's atmosphere from Voyager. It was a lot of old journal work and stuff back in the old library days. We couldn't do it on our fingertips. And even a lot of my ultraviolet data and research and stuff, that stuff isn't in electronic form even to this day. I even had to go to the Library of Congress because none of the libraries had a lot of stuff that I needed quite a few years ago. And they were very helpful down there too. And I got quite a lot down there. And then, when you research, Jim could vouch for this. You find one thing, and that one thing points you to another resource and stuff. So it's a never ending learning curve.
okay, so so there were 4 observations coming out of the first round, and 5 out of the second round, and this was before this event, the first servicing mission, which restored vision to Hubble. That was Endeavour, and of course,
I remember that photo. Yeah.
yes. M100, and of course the instruments that are there now are far better than what you see here. But it was only the third round which got to take advantage of that, and there were only 3 sets of observations selected that time. And at the end of the presentation, I have a slide with all the with a list of all the proposals, and that will be in my article in JRASC as well. But as time went on, there the number of proposals that came in actually was reduced, and I think as I mentioned here, or maybe not. Anyway, at the time there were an estimated 300,000 amateur astronomers in the United States. And although it was felt that they got a lot of really great proposals, they thought that the take up on this wasn't that great, and there was a lot of discussion about this. Now, by the time the third round came around, there was not only the improvements to Hubble, there was also a new director there, Bob Williams, and he ultimately chose to cancel the program after the third round, and there was a lot of discussion about that. The institute had to undergo a lot of budget cuts at the time, and which he had to deal with, and one of the casualties of that was the amateur astronomers, even though it wasn't a great deal of money. But I think part of it was just the fact that there was kind of a falling number of proposals coming in from amateurs, and I think the reason for that was just the huge amount of work involved in making proposals, as we talked about just a minute ago. This is something that's remarked upon by both professionals using Hubble and the amateurs who use it, is that there's a tremendous amount of work involved with each observing proposal. So in the end, there were 12 sets of observations for amateurs carried out on Hubble, and I think the last one was in 1997. So just to move along here, this is just a slide showing that there were a number of servicing missions for Hubble. The last was 13 years ago now, I believe, or 12 years ago, I guess. And it was quite, they did quite a good job on servicing mission 4, because Hubble is still running after all these years. And eventually the gyroscopes are going to conk out, and probably Hubble will stop observations, but they're hoping to get at least a couple of years of joint observations going with JWST. Now, even though the period of giving observing time on Hubble to amateur astronomers is long since passed, it's still possible for all of us, or anybody who's interested, to make use of Hubble data. There's now so much data from Hubble, and it's now all available online. It's much easier to access. Back, probably George and Jim, you probably got tapes in the mail or something like that. Now you can just download it. You get an email saying, here's where you download it.
Yep.
But anyway, anybody can go on to the Sakowski Archive for Space Telescopes, or MAST as they call it, and access Hubble data. Of course, you have to, there is a bit of a learning curve to that. It's all in the FITS format, and you have to know your way around the archive, and but it's available, and there's actually a few things on the Hubble site you can find where some of the processing work has been done by amateurs, or they use amateur astronomers to or observations from the ground by amateurs to complement Hubble observations. So it's still kind of going. On the Hubble site here, you see in this slide, they have some information about how to use the data. Of course, a lot of amateur people are using data from various NASA spacecraft. Most famously, Juno. You know, around Jupiter. They basically threw the camera on at the last minute, and basically they just put out the raw data, and most of the images you see from Juno have been processed by amateurs, or like non-professional scientists. Something about Hubble is that today more scientific papers are generated from the archive than from requested observations, because there's so much data in that database. And I'm just going to mention something else about it. This is a thing where Canada has played a part in Hubble. Hubble is a project of NASA and the European Space Agency. Canada wasn't a formal partner, but there's always been Canadians at the table. And we have actually right here in Victoria, just up the road from my house, at the Dominion Astrophysical Observatory, we have the Canadian Astronomy Data Center. And even they started in the 80s, and were actually fairly advanced and helped NASA and the Europeans develop their archive. So as a legacy of that, there are 3 places on Earth where Hubble data is stored. One is the Institute in Baltimore. The other is at the I think it's at the European Southern, or it's at an ESA facility in Spain. It used to be in Germany at one time, but they moved it to Spain a few years ago. And the third place is just practically within walking distance of where I am at the DAO, at the Canadian Astronomy Data Center. So that's a bit of a Canadian role in Hubble, and Canada is going to be a full partner in JWST, by the way. So our own taxpayers' dollars are going into that. This is just a bit more information. There's the Canadian Astronomy Data Center, and more from the archive at Baltimore. There's also been some citizen science projects. Of course, we all remember SETI at home, but there's also been things like on the Zooniverse, the Andromeda project, or it's also called the FAT, or Panchromatic Hubble Andromeda. I've just forgotten what the T stands for, but anyway, they've taken a very close-up pictures of Andromeda, and they have employed amateurs to find clusters that are actually behind Andromeda in those images, and so
Wow.
there's so that's another thing that's going on. So early on in this talk, I showed you a slide of that proposed amateur telescope, and it would be built by and for amateurs. And I haven't heard of anything going on since that time, but I think if something like that ever happens in the near future, it might be something like this. The MOST space telescope that was launched by Canada, I think in about 15 or 20 years ago. And this is about as large as it's kind of the size of a large suitcase, and it only cost $10 million, which is peanuts for a satellite. So if somebody ever talks you know, a millionaire into launching a space telescope, it might be something like this.
Well, the CubeSats are taking place too. You know, when I was down at Goddard, I met a scientist that I you know, who gave a lecture in New Jersey years ago, and he showed me his lab and his CubeSats and his
yes,
fancy 3D printer making all this stuff. And those things are inexpensive and they're not very heavy to fly. It's just getting them in orbit in telecommunications basically, but they're like disposable, you know, one-shot deals and so forth.
yes. So so that is basically what I had to say. This is the cover of my book, and it has all sorts of everything you want to know about Hubble, but we're afraid to ask, I think. And this is a list of the of all the amateur projects that that took place on Hubble. So I will leave it there. I don't know if there's time for questions, but I'm at your disposal if there is.
Thanks so much, Chris. There actually is a question on the Q&A, and those participating are welcome to send others. Anthony Hillman asks, how much observing time was scheduled and used on Hubble for each of the two proposals that the two gentlemen were involved in?
Now, mine, I added up, my first one was about 43 minutes total time. The other one with the spectroscope was much longer. We looked at 5 asteroids, and each one took more than an hour. Some of them were very, very faint. They were right on the edge of the magnitude that Hubble could see. So we did go for a number of hours for the second round for the asteroids.
Mine was 3.5 hours. I had a slew of 10-minute observations that they actually used a guide star, you know, to track Titan with and lock onto it as it was going around Earth. You got to remember, everything's moving too. You know, Titan's moving, the telescope is moving, and so forth. So it was pretty amazing how they do these things, you know.
It was very difficult with those moons we both imaged, because besides the telescope being in orbit, we also had our planets in orbit, Jupiter and Saturn, and they had the moons going around too. And for mine, it had to be very crucial to get the eclipse at the right time. So it was early on that they hadn't done much work with planets and moons. It was mostly these far distant objects. So they were hustling when they were working on our proposals with our moons.
Yeah, it's a shame the project didn't get as much exposure. I mean, a lot of people didn't know about it. You know, when I was giving lectures, I was telling them that there's another round that you could apply for and stuff. But you got to remember too, this is just pre-web, you know. So everything was back in the snail mail days and all that. So things took a while. So this is kind of how I think maybe in this day and age it probably would have been a lot more you know, better response and better announcements and stuff. But you know, putting in an astronomy magazine, you know, I'm like, that's like the premier next to Sky and Telescope. I think there was an ad in there as well. I'm like, how else can you reach the amateurs, you know, better than those magazines, you know, before everything went like it was going electronic. But it's a shame that it really didn't get as much response. You know, it really is. I mean, a lot of people, you know, would have really had some good ideas and stuff.
Research was a little hard back then. George knows. You know, today you just type in the name of your article and author, and bang, there it is on your screen.
Yeah.
Back then, you went to the library and you filled out a form to get an interlibrary loan, and you waited a week or two. Then they sent you a postcard in the mail saying your article was there, and they had to Xerox it. And sometimes you had to pay $10 for each article. And I had probably a couple hundred articles I did, so it was slow. But actually, I remember the slide rules. Probably George does too.
No, that was before my time, but I still got the floppy disk of the formaldehyde data that I got from the scientists at General Motors. You can't imagine, you can't make up where you got the data from. General Motors, of all people, had the best formaldehyde data that in the ultraviolet. It was just mind-boggling. And then getting in touch with these people, a lot of times I had to go by phone. I don't have their emails. We didn't have the web, back then. So it was like a whole new world.
Yeah, I think it would be, much easier to do and much easier to publicize, with the internet going than it was when you were doing it. I also think that, the spherical aberration thing really affected things. There's all this publicity,
Yeah.
Hubble isn't working and there's all these problems. And for a time in the 1990s, Hubble was kind of a byword for failure. There's that famous scene in Naked Gun, things like that. It became a big joke, but then it was fixed. And
Yeah, it's the rest is history, Yeah.
That's right.
Yeah, like
Sorry.
yeah, like like me and Jim. I mean, the spherical aberration problem, didn't affect us. I had spectra data, and Jim had images that were in the solar system neighborhood. So it was not that it was not a burden for us. That's what we explain to people when they ask.
Well, thank you so much, gentlemen. This has been quite interesting. Knowing what technology has done for us in terms of not only the telescope, but the technology we had to gain in order to have improvements to this particular piece of equipment, as well as the science that you folks are conducting. So thank you so much.
And yeah, thank you. And thanks to George and Jim. It's really great having you along and sharing your experiences with us.
Yeah, okay. Next is our second presenter for today. He is from our center, actually, and I met Tony Schellinck, who's our next speaker, out in the field in the dark, actually, for the first time, with a pair of binoculars in hand, back in 2013 at my very first Nova East Star Party. I've learned a lot from this dear soul. He is certainly an avid observer. He's received 3 certificates from RASC, one for Explore the Universe, the Messier Catalog, actually 4, NGC's Finest, as well as Explore the Moon Telescope version. In fact, Tony, I think you were one among the first to earn that particular certificate with respect to Explore the Moon. Through his experience, he's learned the value of sketching. I think those of us that do sketch for a very good reason and try to impress upon others the value of it. So without further ado, I will leave it to Tony to show us how, for those of us that are new to sketching, and explain the benefits thereof. Tony.
Well, thank you, Judy. Let me see. I'm going to hit share screen here. And all right. Can you see that?
Yes, we can.
Okay. We're all set then. All right. When Judy first asked me to give a talk, I was a little taken aback because there are so many other people in the Halifax Center that are excellent sketchers. So the question was, well, what would I say? What would I do? And I realized that, as Judy just said, I've gone through the whole process, starting as a complete beginner getting into sketching and coming through that. And if I can relate my experience, what I might be able to do is help people get over that hump where they say, I can't sketch. I don't know what to do. This is difficult. I want to just observe. You're listening, Linda? So that's what I hear. And so that's the kind of the goal of this presentation. So I'm going to take you a bit through my journey, and I'm going to focus on the Explore the Moon telescope. So I'll introduce you to that program and tell you a bit about the resources that are available. And then in the last 7 minutes, I have a video of me sketching so that you can actually see how it's done. The end product is not necessarily nearly as good as some of the other people would do around here, but it's good enough that I think you people could, the people who are beginners or hesitant to start sketching, could say, yeah, that's something I can do, and that doesn't look too bad. So when I got started, the first thing I did, of course, was look for resources. And I went to the RASC website and found Carol Lacomiac's tutorials, and she has 2 of them. And one is the how to sketch moon features, and the other one is how to sketch deep sky objects. If you go to RASC Home Observing Astro Sketchers, you will see her tutorials there. There's also some really good tutorials that are available on YouTube, so that you can just do a search there and find those. So she has 5 steps, and she starts off by saying, okay, just all you have to do is sketch in outline form, very rough, the objects you want to sketch in the end. And then she goes through 5 steps, which I'll briefly cover. And in the end, she ends up with this. Now, what's interesting about this is it looks fairly realistic. And that's because there's no actual lines left by the time she gets to this stage. And she has shadows and detail and gray, various shades of gray, which gives it a 3-dimensional feel. And that's really what you're trying to accomplish here. You don't have to go that far. It doesn't have to be this nice looking to be effective for what your purpose is for observing. And I should point out, the reason you want to get into observing is not just to create images like this. It's because when you're observing and you're sketching, you're really observing. You're seeing the details that are there and you're putting them down on paper. You're seeing the shapes, you're seeing the relative sizes, you're seeing the shadows, you're seeing all of this. And when you can go back and look at this and then look through the eyepiece, it should help you recognize what you're looking at. So it becomes a tool that you can use for observing. Now, just to check, Judy, can you hear me okay? And is everything working?
So far, yes.
Great. Okay. Then she outlines 5 steps. And I'm going to be covering these, but I don't quite do them in the same way that she does. So she says, roughly outline the main features. And you saw her initial drawing there, and it's not very detailed, but it gets the shapes and the sizes of the main features you're looking at. And then you add the shadow and sunlight lines. And as she points out, the terminator near the equator moves at about ½ a degree every 10 minutes. And so that means both the shadows and the sunlit areas are going to change their shape quite quickly. And so at this point, you wanted to complete outlining where the shadows and the sunlit areas are in the space of roughly 10 minutes. Now, these first 2 steps you have to do at the eyepiece. Now, you can do all 5 steps at the eyepiece, but you can, if you want to, once you collect enough information and put it on your actual sketch, and this is not necessary in drawing. I often put a lot of notes on my sketch, and you'll see some of my sketches, as I step away from the eyepiece, it's just full of text and arrows and all that sort of thing, all of which I eventually erase. So steps 3 through 4 through 5, I usually do in my warm room. Step 5, I sometimes do on a sunny afternoon sitting in my living room if I have the urge to really work on these and finish them up. So in step 3, you lightly shade the crater floors, but that's just part of the whole shading using a softer pencil. Then you blend the crater floors with a blending stump. So there's a whole bunch of work that you do with blending stumps, and I'll show you that in the video. And then you basically finish it. So those are the 5 steps. And I said she has 2 tutorials, and as Judy said, I have completed the Messier 110. And when I was doing that, I did some sketching, which I'll show you briefly. I've done the NGC Finest. I did the Explore of the Universe, and this one. And in all of them, I've worked hard at sketching, and my sketches have changed as I've progressed, and you'll see that as well. So here is one of her sketches of the Sombrero Galaxy. Now, I don't want to say it's easy, but you can see here, all we have is 4, 5, or 6 stars. The brighter stars are made a little larger in the diagram. And then often for these, especially with nebula, all you see is like a smudge in the middle. Now, everything has to be in the right place and the right size, but it's really not that difficult to do a deep sky object sketch in comparison to do the moon. And in fact, if you look at my photograph here, okay, where is it? There it is, of the sombrero. This is my photograph. You can clearly see where the stars are. And if I go back to her diagram, you can see the stars are in exactly the same place as where my photograph is. So she's done an excellent job of catching this. And here is a sketch of a globular cluster. And here is a slightly different globular cluster that I've taken a photograph of. But as someone told me, all globular clusters look the same after a while. So anyway, but you can see this will be a lot more work getting all the little spots, but it's not that difficult. And so here were, when I was doing Messier's list of 110, these are the kind of drawings, the sketches that I did. And you can see, as I say, white dots and smudges. But and as we go into our own solar system, there's a lot of other things that you can sketch. So Mike Gatto here, you can see he's got Jupiter. It must have been a very clear night to get this much detail, but I've been there. And what he captured here was the 2 moons, Io and Europa, plus their shadows on Jupiter. So you can see this is a lot more complicated than if you're just doing a deep sky object. Here's another one of his of Mars, and I'm sure he's produced some in the last year of Mars that are probably even as good or better than this. Mike Bolshat also does sketches, we see, and you can see here we have a comet, and pretty straightforward, but it does the trick. And here's one of his craters. Very simple, but you got to remember, what's the purpose of these sketches? The purpose is to capture the detail that's important to you when you're observing, and that's what he's done here. Now, you've seen at the beginning of the meeting, you saw several of Mike Gatto's recent drawings, and they look spectacular. Well, here's an example of one from, that's 15 years ago now, but I want to point out why this works. And the reason it works, if you look at this, and I could presume you can see my mouse, see this line here? This is not a straight line. This is capturing a lot of detail. And this shadow here is just not a line going across. It's following a pattern. That adds realism. And so you know he's actually capturing the actual features and details that are there. And it's an excellent use of white space. People don't realize that when you're sketching, you can use the white paper, the white space that's there, to create it, and then you have various shades of gray. And really darkening in the shadows because there's no atmosphere on the moon. So the shadows, in fact, are really dark and sharp. And so you have the ability to really make these dark, and that makes it really dramatic, would be the right word. So you can see the use of white, the shading, the really dramatic black, and the detail of the features that he's made the effort to create. If you're looking up here in the upper left, he hasn't done much with this crater in comparison to what he's done with this crater. So that's part of the secret of drawing, is to work on the detail, use the white, the gray, and the very black for these. Now, I said I did explore the universe, and that was the first time that I had to sketch something on the moon. And even though you all have mute on, I can hear your collective laughing. Yes, this is pretty rough. However, it does the trick. And this is me getting into sketching on the moon. So, yeah. So, oops, sorry. So we have up here, I've got Clavius, it's smooth floor, there's no dimple, small craters around the edge. I say when I did this back in 2017, what's this location? And you can see where the shadows are. So this is pretty rudimentary, and this is how I got into it. But at least I got into it. And I did this with the ETU, and I said, okay, I can go from here. So I had, there's quite a few of these. And if anyone's doing the ETU or any of these, then they should be sketching whatever they see. And so I took that on and sketched these. Now, then comes along explore the moon with a small telescope. And we have to thank several members, chiefly Dave Chapman, but several other members of the Halifax Center, because they put a lot of effort into making this happen. And I have to say the documentation is absolutely excellent. It's very helpful, very clear, easy to use, and I could understand it. And it made it easy for me to jump into doing this project. However, there's nothing on sketching in this documentation that I saw. Correct me if I'm wrong, Dave, but I never saw anything on sketching. And I think that would make a real contribution to this particular program if they had a section and even referenced Carol's website on the RASC Center site that they can do sketching of the moon. So anyway, a small suggestion. Now, the thing about this project is that really there is minimal equipment required, and a small telescope, and away you go. Now, if you're going to do sketching, though, I would recommend that you might want to use a larger scope, not just a small scope. And you want a good steady mount, and you want to be able to go to higher magnification. The range of magnification that I used ranged from a low of 80 times magnification up to 675. And depending on what you're targeting is what magnification you would likely use. And one of the really good pieces of documentation is that they have a whole series of photographs of the objects that you're going to target. And this is excellent. Thank you, Robert Reeves, for the images. And here we have an example. So if you were going to target Atlas, you'd want to go to this page, take a look at it and say, now I know what I'm going to see when I look through the eyepiece. But that's not what I used. What I used was something called Moon Globe. And Moon Globe is an app that you download onto your cell phone. So it's on your cell phone. And it's cheap, easy to use, and has a lot of good features. So first of all, you can see at the bottom left here that you can flip it north, south, and right and left. So you can ensure that you get the same image on your cell phone as you're going to see through your eyepiece. Secondly, the terminator moves in such a way that what you see on the moon is what you're going to see here. And so you can, that means you can pick, well, first of all, it makes it easy to identify the objects that you're targeting. And that's one reason I use the moon globe, is to make sure I'm actually looking at the crater I want to look at. And secondly, it shows you which ones are appropriate to target for that evening. So when you're setting up, you're planning to actually, what can I draw tonight? Then you can sit this down, set the time for when you'll be observing, and go from there and see what you can see on the moon. So now I do have a log. So this is where it might get tricky. We'll see if it works. And interesting. That's not what I want. Excuse me.
The other window. Yeah.
The other window.
The tab. Sorry.
Okay.
In-
Okay. Over here.
Yeah,
Oh, there we are. Yeah. Thank you, Jerry. It's good to have an expert online when this happens. So when I submitted my log, it didn't look like most people's logs, I suspect. What I did is I took pictures of my sketches, and I included that here. So in the end, there were approximately 90 targets. I'm excluding the landing sites for the various visitations from Earth. So there's approximately 90 features that you might want to sketch. And here they are here. And you can see that actually they varied quite a bit as to how I would do the sketches. Sometimes there was a lot of empty space around, but other times I would fill the whole area where I would be the view through the eyepiece, in other words. And then sometimes it even didn't fit in the eyepiece, and I just sort of shifted things a little bit to fit it in. So there are 26 of these, as you can see, and some of them, wow, they look really good. You know, number 18 over here looks pretty good, and these aren't bad, but some of them still look pretty amateurish. And are you seeing these all right, Judy?
Yes.
Okay. You know, as I got better, for example, when I did Kepler here, these rays I worked hard on making the rays actually look like the rays look like on the moon. I just didn't sort of create artificial rays. And same over here. And so, you know, you get, it boils down to the same old thing. Practice, practice, practice. As the more you do this, the more sketching you do, you learn things, and they get better and better. And that's the only way you're going to really improve. So I did 26 of these, and sometimes just one object was there. Sometimes I had you know, if you look at some of these, I've got a lot of objects here, for example, and that are in one view. But you see, what have we got here? This is 200x. Most of my work was done between 180 and 250x. But sometimes, and where are we here? Sometimes, for example, this one, I'm 675x. So to get these, I wanted to really zoom in on them. And and I had the advantage of using a 16-inch Dob. So going to 675, yeah, it's not a problem. And if I had a 70 millimeter sky something or other, that would be a real problem. I probably wouldn't be able to see much. And so went along, and of course I have my log here, and so these items are on the second diagram, second sketch, and the date that I did them, and away we go. So this is what I basically submitted to the committee, and for some reason they actually accepted that. All right. So that's the log. And so this was my second sketch. I think it's 3 of the 4 gang of 4. Dave, you can correct me if I'm wrong on that. And so the first thing I had to do was learn how to navigate based upon the Explore the Moon documentation. So they have these wonderful maps there, but it doesn't necessarily translate into what you're seeing through the eyepiece. So that was a bit of a hurdle to overcome. While I naturally use a red headlamp, the advantage of this is that the moon is so bright that if you use white light on a headlamp, it works just fine as well. You had to pick your targets in advance, and you could only do so many per night because only so many of them were actually had the right amount of illumination and shadow. And so you might do 2 or 3 a night, but you could obviously capture far more targets because you might capture 9 targets in those 3 sketches. How much to zoom? Like I said, I went from 180 to 250 usually, but could go as high as 675. And that depended on the number of targets and how much time I had. The seeing was also a factor. So that's something you just sort of look at it and you say, what's going to work? And I tried different things, and away I went. So in terms of equipment, you think, well, gee, I need really expensive equipment here. Not so much. So my standard sketchbook, I purchased at the Great Canadian Dollar Store in Liverpool. I just bought this one 2 days ago for this photograph, $3. And it has 60 sheets. Seems to be good enough quality for my purposes. And you can see I just use one side of it, and a yogurt top makes the circle, and away I go. Now, my wife recommends that you don't actually forget that you left your your sketchbook outside and leave it in the pouring rain for 12 hours because it takes a long time to dry it out afterwards. Then you have the tools for drawing. Now, the aforementioned Greek yogurt cover for drawing circles, standard stuff here. The pencils here on the left, you can buy 10 of them for $3 at that same dollar store, or you can go to Michael's and spend $30 and get the same pencils if you like. I'm sure they're better quality. The 2 most important tools here for drawing, though, are the blending stumps, or that you see here, and they're just made up of rolled up paper, and they're critical for creating the smooth gray color or gradient of gray to create a 3-dimensional effect and to create realism. But the most important tool that you have for sketching is the eraser. And I actually went through quite a few erasers before I found one that really worked. And you'll see in the video that eraser does a wonderful job. So get a Staedtler if you're going to be doing sketching. The sandpaper is also very useful for sharpening your pencils as you go along, cleaning up the blending stumps, and cleaning up the eraser. So here we have a picture that Graham Hill took, and we can see that there's 2 prominent craters in it and 2 mountain ranges. So my image of this looks something like this. So it's 180x, so I have a lot more in my image than he has in his photograph. But if we kind of zoom into this aspect of it, we can see here that I kind of fit here. So what I can see is I've got my most of my craters in the right place and the right size. And oops, sorry about that. And if you look at the mountain range, you can see my mountain range looks a little different than his. And the reason is, if you look carefully, you can see that the shadows are on the right side of the craters here, and the shadows are on the left side of the craters in my sketch. And what that really says is what you're seeing will vary dramatically based upon where the sun is. Either you're talking about a couple of days later, as Paul pointed out, or if you're talking about a waxing moon versus a waning moon, it's going to look very different. Now, you might wonder, what is this gray smudge over here? Well, that is the Mount Archimedes. That's my rendition of that. So as you can see, it's not a lot of detail. So that's that. So I see two main phases when you're sketching. One is at the eyepiece, and in my case, the second is in the warm room. Now you can do it all at the eyepiece, and that diagram, that sketch that I showed you that Carol did, she says it took her an hour to complete that sitting at the eyepiece. I don't have that patience. I got to move out and be a little bit more comfortable and have a little bit more space to put the sketch pad down and my tools and to work on the diagram. So this was actually the very first one I did for the ETM. It's pretty rough. I was still learning. And finally, this is what I submitted. And it looks a little wavy, the paper, like the aforementioned incident with the rain and leaving it out, but it still looks okay. All right. So to show you, to illustrate the process and hopefully make it seem easy. Well, it is easy. This is the sketch that I'm going to use, another one of Graham Hill's photographs. And we have Katrina, Sirius, and Theophilus craters here. And the red circle represents what I'm assuming would be my view through the eyepiece. Okay. Now, so you can see in the upper left, hopefully, what I'm going to be drawing. Let's see. All right. Let's see. Oh, here we go. So I have many, many Greek yogurt tops that I save for this purpose. First thing I'm doing here is I want to find the location of these, their relative location, and their relative size, and their absolute size. Those are things I'm trying to capture when I'm doing this. And you'll see here, oops, that's too big. Bring out the eraser, the sketcher's friend, and fix it. So you'll see all the way through this video, I'm constantly fixing it. By the way, the total video, if I hadn't speeded it up, was 28 minutes. So there's 28 minutes of sketching here. But don't worry, it's about 7.5 minutes with this video. What else can I say here? So what I'm doing is capturing the outlines, a little bit of the shadow at this point. And so in that case, I put that crater too close to the other crater. And then I looked up and I said, no, no, no. Yeah, so, whoops, that crater there should have been a little bit further away. And at this point, I'm deciding what features I'm going to include in my sketch. And I'll tell you a little bit more why I select these a little bit later, but I'm going to ignore a lot of the features that are there because, well, there's just too much detail in this view to really worry about capturing it. I want to capture the more interesting ones. And so there we go. So that long ridge looks quite interesting to me. So I'm capturing that. So then once that's done, I start to fill in the light areas and the dark areas. So here you can see I have filled in where the shadow is. And as I said, you want to do that in a space of about 10 minutes. So you can see these here and the detail. And so at this point, I'm starting also to draw a lot more detail, but I'm going to be erasing a lot. So you can see here that the final sketch, you want to do away with lines. But right now, what I'm doing is I'm trying to catch that detail, similar to what you saw Mike Gatto does with his, that he doesn't have straight lines. He has wavy lines with detail in them. So you see the edge of my crater here. It's not a straight line. It's basically following what I think is the outline of the floor of that crater. I'm also at this point starting to put in other dark spots that are around and capturing those things that I didn't do when I was doing the main sort of opening sketch to sort of capture the main features. So now you're adding a lot of detail and deciding where the shadows are, what your details you're going to catch, and so on. So once you get so far down, you can start doing things like darkening in the shadow. So I've gone to a much darker pencil here than my standard HB pencil. And now I've got a blending stub, and this is my bigger one. And you can see that the graphite in my HB pencil obviously is easily spread by the stub. So that's a secret for making it more realistic. So you want to blend both the different colored gray areas plus the dark area to make it very solid and not streaky. So there you go. And so we continue that up here. And you can see that, well, you'll see. So you turn this, I'm just using one pencil to do this. You don't need a lot of pencils. And there's my friend, the eraser, when I make a mistake or I don't like what I see, or I look back at the original through the eyepiece and say, oh, that's not what I'm seeing. Now, the funny thing is that in my original drawing, I had a lot of little features that I put in. And as I'm going through this process, sometimes I inadvertently delete them if I'm not looking at through the eyepiece. Now, one of the things that you'll notice I just did there is there was a line up here. And when I use this, the blending tool, what I'm doing is deleting the lines. And I'm doing that by pulling the graphite that's in the pencil mark away from that pencil mark using the stub. And that gets rid of the line. If you have lines left in your image, then it doesn't look that realistic. And so eventually all these lines that you see here will disappear. So, and I keep referring back to the photograph here just to make sure that I'm capturing the detail that I want, because detail adds realism. So watch me get rid of the lines here that around these particular little craters. And when I make a mistake like that, you see how white that particular eraser made the paper? And that's important because as you saw with Mike Gatto's one, you want to make good use of white, and it's very easy to inadvertently, either with your stub or a pencil, to go into what you will hope to be your white area. So you want a good eraser to bring it back to whiteness. There we are. So the degree of gray is a function of how hard down you push your pencil and the density of what you do. So you can see that the area outside of these craters is going to be very light gray. Now you might wonder, why is he spending so much time on these three little craters down at the bottom? Well, when I'm doing this, I'm thinking back to the time when the astronomers didn't have photographs, and that they wanted to revisit this particular set of craters, and they needed an image to help them identify it, something very distinctive. So here I am cleaning my eraser off with the sandpaper. And so I look for distinctive patterns in what I'm looking at that will point me in the right direction, north, south, east, west, and I will recognize it because, you know, frankly, a lot of these craters, it's hard to distinguish them from each other. And sometimes, given the lighting, it's hard to figure out, is that really the crater I'm looking for? So if you have little features like those three there with beside the other one, then that helps you identify them. I also like to, eventually I got to this, was create gradients of gray all the way across to capture the fact that the terminator is right there. And that's why I make the side there dark. So all I did here was initially draw a general outline and then darken in the areas of the shadows. And that was a process sort of continued. Did the floors of the craters and the surrounding, and then worked on the surrounding areas, and then worked on taking away the lines and then sort of stepping back and covering the whole thing with the gray. Now, in an area such as this over here, there's a lot of detail that I just haven't bothered to draw. I don't need it. For my purposes, the detail that I have in here is all that I need. And if I've captured a particular moment, and this is the final from my movie. Now, I would probably not finish with this. You can see up here that really I need to darken this and make it smoother. This is really rough over here at this point. And so if you want to get an appreciation for this, I would work more on this, but if you want an appreciation of this, then you have to move your computer screen about 6 feet away from you. If you move it 6 feet away from you, you look at this, it'll look pretty good. If you want to put your face 6 inches away from this, it won't look very good at all. And that's okay, because I like it from 6 feet, so that's what's important to me. Anyway, this is the basics. You know, it wasn't that hard to do that. You saw me doing it. There's no reason why you won't all suddenly run out the next opportunity you have and sketch. And what I think we need is what I call a sketching certificate program, where we say it could be a subset of the ETU, for example, and where we say, if you submit this, or you should submit this with the ETU or something like that, and we give them the materials and the references and the videos to go along with that to help them learn to sketch. And we need to do something like that. Anyway, thanks very much for listening. And if there's any questions, I'm happy to answer them.
Thanks so much, Tony. At this point, there aren't any in the Q&A or in the chat that I'm aware of. I'll just check the chat again. But I'm going to unshare your screen on your behalf, if that's okay.
Yeah, go ahead.
Just a comment, it looked great from about 9 feet away.
Okay.
And our illustrious editor, James Egger, pointed out that there is a chapter on sketching in the OH. So
as well,
that there's something in there as well. A member from Saskatoon apparently wrote that one. Kathleen Houston. Yeah. No, sketching is something that, as you pointed out a couple of times, is something that is learned as you practice it. Because I always said jokingly that when I first started sketching, I was hesitant because growing up, there was always this disconnect between what I saw and what I draw. I thought there was a disconnect right about here because my hand would not do what my eyes saw. But with practice, it is getting better. It's not to my Gatto status by any stretch, but the true benefit of sketching is that it does bring you back to that moment and as you said, helps you identify patterns of the craters and everything, all the other features that are on the moon and where they're located. So that's important.
Right. One of our problems is, and no offense to Mike Gatto, is that we tend to show sketches like Mike's, which are fantastic, and then everyone else looks at it and says, I can't do that. And so maybe we need to start, illustrating that it doesn't have to be that fantastic. That your sketches aren't supposed to be. There's always someone who's going to be able to do a sketch way better than you can, but that doesn't matter. That's not the reason you're doing it. You're doing it for purposes of observing and self-gratification. You want to get to the stage where you like it, and that's what's important.
Keeping in mind too that Mike does have a graphic artist's background, so that certainly puts him in.
He's cheating.
Yeah, people like us who are out of that picture. Well, thanks so much, Tony. Oh, wait a minute now, there's a question. What was the square blob of black on the palette?
Oh, I'm sorry, I meant to say that. That's another eraser. And for those of you who are into sketching artistry, you know that these are the ones that you can manipulate with your hands and point into a point, and then erase very fine points. And the way Carol says it, you should use that to scrape off, in a sense, the carbon that's there if you want to, and also lighten up very small areas. I confess that I have yet to really master that particular piece of equipment, although I know other people who are sketch artists and do nature and all that, and they love it. So that's up to you, but thank you for asking. That's what that is. And it generally that comes along with any kit that has sketching instruments in it.
Okay, and from Linda says, do you make blending stumps or purchase them? And if so, where?
Those that you saw in the diagram were purchased, but I teach sketching in the seniors college as part of my observing course. And for that, I don't want to go out and buy, 40 sets of blending stumps. What I do is I take paper towel and I fold it up and till it gets down to about, the yay big and about that thick, and I staple it. And the three corners that are out there work very well as blending stumps. And and sometimes I just use that the folded up paper to do the trick. But no, that is a good investment though, to go out and purchase blending stumps.
What types of pencils, number 2? Ever the mechanical pencils? I guess has ever used the mechanical pencils?
No, if I understand the question. As you know, there you have HB, and when you get them, they range in from 8H to 8B, and also if you get sketching pencils, they're charcoal and they're really dark, and you can make good use of those. And I don't use them all, but good sketchers probably do. I'm not sure if I understood the question, so my apologies.
Yeah, no problem. Okay, well, thanks so much for taking the time with us. And I know you're enjoying some life down there on the South Shore, where it appears to be quite sunny right now.
It is. It's gorgeous here.
Yeah. All right. Yes, you do live in the best part of the province, I believe, for observing too. So thanks again, Tony. Okay. I'm going to share my screen a moment. Next up is Paul Heath. Paul is our outreach chair, has been for a few years, and he also happens to be our resident poet. Where are we here? Share screen. I can't share my screen. Why not? Who can share? Only host, all panelists. All right, try that. Help. Tech is here.
Your hand is up
Uh,
on your thing, your raised hand. I don't know if that's a problem.
Yeah, no, it's not. But here we go. So Paul, your poem is Namesake I. I leave it with you to take it from here, if you
Okay.
would, please.
I don't see, all I see is a ghost of the Hubble with the title.
Oh, sorry. Guess it would help to have that, wouldn't it? My apologies.
Okay. As most of you know, I try to write my astronomy poems based on the topic of the day. And I try to make people look at it sort of outside the box, have them recognize the emotional aspects of the topic. So sometimes it's easy, sometimes it's a little harder, but this one was fairly easy. Okay, namesake I. Long nights in patience sat, his eye held to the glass, until faint wisp of light revealed that they, beyond our whirling home of stars, did dwell. With joyous hubris we launched above the skies his namesake eye. Yet through joyous tears our vision blurred, until a cry arose to mend his eye. In glorious hopes we rose into the sky, mended and improved our eye. Images beyond our wildest dream poured upon the pages of our colored magazines. The glory of the universe now seen. Then, in the silence of an endless stare, we reach within a darkened moat, gathering on a thousand flickering nights, a billion souls we collected from the darkest night. Our world was shrunken beyond our dreams as the universe hurled out beyond light's speeding need, back to time when man had never been, and whirling stars were newly seen. His namesake eye, the universe unraveled. Wonders filled our eyes. From out the deepest, darkest night, yet a cry more was heard, was overheard. So for 100,000 flickering nights, a million, billion souls we collected from the deepest, darkest night. A legacy of knowledge we have found. Out now from this tiny grain of sand, the universe has stretched outbound, unbound. For we have in wonder peeked through his namesake eye. So, I hope that does justice to the telescope.
Thanks, Paul. It does
Thank you.
indeed.
Yes, it does.
Okay. Well, thanks so much for that.
Yeah.
Next on the agenda, doesn't like that button, is our members' question period. Last month, as you know, there were 3 questions that we had, and we had emailed folks who had been members for the past, just for the past 2 years, new to the organization, and they had provided some questions. This month, we put it out to the general membership, and we haven't heard from anybody. So I'm hoping that, is there anyone out there that has a question about any aspect of astronomy? Whoops, sorry, or our
That's the first site we saw through Mark's 25-inch telescope, the Sombrero.
is
That was the
obsession.
first image, yeah, the 25-inch, the first night.
Yeah. So that my question to the membership is, anybody else that has a question about any aspect about astroimaging, binocular viewing, any aspect about RASC, anything at all?
I have a question for Tony. Those little opera style binoculars that are maybe two power, I think you had a set of those. How did you find those?
Tony, you're muted. Sorry, dear. I'm going to stop share for a moment.
He thought he was done.
Probably. Yeah.
I can guess where he went.
Yeah. There was a question from Karen, and she's asking me actually, how am I enjoying the XYZ mount on my iPhone? I am thoroughly enjoying it. For those that aren't familiar with it, it's a unit that you clip onto the eyepiece on your telescope, and then you put your, well, I have an iPhone, so I put my iPhone in it and then adjust it so that I can then see on my iPhone what's in my eyepiece. It has helped when I go to sketch because then the image is slightly bigger. It's, as Dave described it once in an email, it's a bit softer image than the really clear one that you get in your eyepiece. But the other benefit of it is that I can use my iWatch from a distance to snap a picture. So I'm not having to touch my telescope and jiggle it by taking a picture, by actually touching the iPhone on the eyepiece. I can use my phone as a remote camera to click on it. And that way later, as Tony mentioned about going into a nice warm room to draw these drawings, you get the basics done at the scope, but then you have the photograph later to refresh your memory, especially if you don't get around to it in the next couple of days for whatever reason. So I'm loving it. I think it's great.
I think we can add that for better or worse, with a 2500 millimeter 10-inch Meade SCT and a 4.7 millimeter eyepiece, that the phone doesn't provide any eye particles in its view, whereas with my old eyes, I get lots of floaters and such. So those all disappear when looking at the screen.
Yeah. Unless, of course, your phone or the eyepiece have dust on them, then it certainly shows that up too, but that's minor. Okay. All right, well, given that, we'll call that a close to the members' question period. Next is Dave Chapman. He is our observing chair. And Dave every month provides us with a wonderful presentation on what's up in the night sky. So Dave, what's up in May?
Well, thanks for that, Judy. Before I do that, I see that Tony's back now. He missed an opportunity to answer a question that
I'm sorry.
That's okay, man. It's my time now. Anyway, I wanted to great minds think alike. I wanted to show you my sketching outfit. I've got this little box here, okay? And I just happen to have it here at the desk. And my sketching pad is palm size. That's what I take to the telescope. And if people can see this, if I can do this, that is my sketch of, just a second here now, Cassini, from about 11 years ago when I finished the Isabel Williamson. I didn't sketch while I observed because I was too focused on, getting the damn thing done. And if you sketch everything of the 500 or whatever things that you're supposed to see, you just never get done. My wife said to me, "What are you going to do now that you finished?" I said, "Well, I think I'll go back and grab a couple of craters and sketch them." So I did. I went back and once I had gotten my certificate, I went back and started sketching. So it is a lot of fun. And I have a similar kind of kit that you have. But I just wanted to point out that if you really want to go to the next level, Tony, what you need is one of these guys. It is a, what is it called? It's a Tough Stuff, Papermate Tough Stuff eraser stick.
Oh
and it's like a little pen, and you can do this, and you can get in there, and get the eraser right into little spots, and you can use your sandpaper to whittle that down to a little spot. So you can't get those at dollar store. You have to go to Michael's or someplace
I
like
have
that.
to spend money. Oh my God.
Well, if you want to get, into the Gatto level, you really got to get some more gear, All right.
So just very quickly, the question about mechanical pencils. Pat Kelly here at Halifax Center said, I use 3 different size mechanical pencils for putting stars in deep sky sketches. Touch the paper, rotate 90 degrees, and you are done.
That works.
Yeah.
Okay, let's get going. Yeah. So I'm hoping everyone sees my title slide.
Yes, thank you.
Okay. So this is the what's up for this month. And it just so happens that our meeting starts on the 1st of May, on the 1st of the month, which is not always the case. And for the people who are just joining us, I create this using the Observer's Handbook and a program called Sky Safari, which is my go-to app for this kind of thing. And as always, we start with the sun. And I'll remind folks that this presentation is available on the Halifax RASC webpage, on the splash page, as it were. So there's a PDF version of this page, so you can go and look at it anytime. And any links that are in this presentation are active on that PDF. So up here on the top, in the top right of the page, there's a link there to today's solar activity. I'm not going to go there because it doesn't work very well with Zoom. But if you go there, it'll show you the sun in all kinds of wavelengths. And we know the sun has been active lately. Our member, David Hoskin, has been sharing some amazing images from his new Lunt solar telescope, and we've been enjoying those. So we're getting, closer to summer. This is the last month of spring, and the night is shrinking down as the month progresses. So we go from having about almost 6 hours of darkness down to just 4. So dawn comes very early, and dusk is very late, especially now that we're on daylight stupid time. So it doesn't get dark until after 10, and it gets worse. So I have these little pie charts here which show that nicely. And again, for the people who are new to this presentation, at the lower right, there's a link to our RASC Halifax YouTube where you can see a video animation of these pie charts going through the year. So the sun's getting higher in the sky and we're getting more daylight. The moon this month, the last quarter is upon us in a couple of days. So to observe the last quarter, you'd get up in the morning, not at night. And as the month progresses, the moon passes by Saturn and Jupiter at dawn. A new moon is on the 11th. And here in Mi'kma'ki, which is the land of the Mi'kmaq people, that is the start of the frog's croaking moon. And in Mi'kmaq language, that's Skolchuigus. Skolchuigus. And the person who taught me that, he said that Skolch is the name for frog, and that it's one of the many names in Mi'kmaq where the sound of the word reproduces the sound of the animal. So Skolch is supposed to be a croaking frog. And I said, well, normally it's the peepers we hear. And he said, well, yeah, but you have to choose one. You have to choose a word. So they use Skolch, even though peepers go peep. Anyhow, so it's the frog's croaking moon, and that will be full on the May 26th. And because that's the same day as the perigee, there will be large tides following. And of course, here in the Bay of Fundy, we get very large tides. So that's something to look forward to, unless you're prone to flooding, in which case maybe you should be careful. So it's very interesting during the first part of the cycle, because on the 12th of May, we have a young moon, 25 hours, and Venus will only be 1 degree apart. In fact, Venus is occulted by the moon, but not in our part of the world. You have to be on the other side of the world to see that. And the next day, we have a 2-day moon and Mercury, 3 degrees apart. And a couple more days after that, we have the moon and Mars. So there's a little parade there where the moon goes by all of the planets. So there's some pictures there at the bottom showing on May 12th and May 13th what the circumstances are with the moon and the planets, and a 5-degree circle which more or less represents the binocular view. I have more to say about the planets coming up. Well, right now, in fact. So Mercury, I've got that in red. This is the month for Mercury. It's going to have a greatest elongation east in the western sky on May 17th, 22 degrees away from the sun. And the ecliptic is at a really good angle, so it's going to be high up in the sky. And this, for us in the Northern Hemisphere, this is the best apparition of this year. So if you like looking for Mercury, and especially if you've never seen Mercury, if you want to find Mercury, this is the time to do it, because it's going to be relatively easy to find Mercury this month. As I already mentioned, it's in conjunction with the moon on May 13th, low in the northwest. And then later in the month, much later in the month, it's going to be in conjunction with Venus, May 29th, low in the northwest. Now, there's a diagram there. It's very close. I mean, they both appear in a telescope view. The only trick is that Mercury is going to be quite a bit dimmer at that point. So, but if you find Venus, you should be able to find Mercury. So the challenge is to go out and find Mercury at some point and identify it. And if you can see it in conjunction with Venus, you get bonus points. So as I said, Venus has been in the morning sky for quite a long time, and it's now an evening star low in the northwest. And we've already mentioned that it's in conjunction with the moon on the 12th and with Mercury in the 29th. It's going to be around for a long while in the evening sky. Mars is fading, from last year's opposition, but it's still in the western sky. Quite a bit dimmer than it was at opposition. But if you want to look for it, if you want to find it, look for the moon on May 15th. And in the picture there, I've got a star Epsilon Geminorum. It looks like the moon might be in the evening, might be just past having occulted the star. So if you can catch it early enough, you might be able to see that reappearance. Jupiter and Saturn are in the southeast morning sky. They're visible for half the night. So if you're an early riser or a late night person, you can start observing both Jupiter and Saturn after midnight, I would guess. And as I said, the moon passes the planets on May 3 to 5th, and again on May 30th to June 2nd. Uranus and Neptune are basically too close to the sun to observe, but will come into the morning sky before dawn in a month or so. As far as the moon is concerned, in Explore the Universe, there are a couple of dozen targets that you must observe, and you only need to find half of each of those. So it's nice to get out with the binoculars and try to find those. The evening apparition of the moon this month is from the 12th to the 26th. That'll take you from a young crescent to, a full moon. So there's lots of opportunities there to find things on the moon. And while I'm speaking of the moon, on Thursdays, the RASC is running a course called Moon at Noon, which is actually 1 o'clock here. And who knows what time it is in Victoria? Probably what?
9.
9 o'clock in the morning. Anyway, not too early. So that's kind of a fun thing to tune into. It's only half an hour long, actually. And there's a few panelists there, Jenna, Samantha, and John Reed of Halifax Center. And I sort of hang around in the background and kibitz. So speaking of Explore the Universe, this is the last month of spring. Next month, I'll be talking about the summer objects. So these are familiar constellations of spring: Ursa Minor, Ursa Major, Bootes, Leo, Virgo, and Libra. So if you're starting to explore the universe, these are the constellations you should be looking for. And the stars in spring, ranking from brightest to dimmest: Arcturus, Spica, Regulus, Dubhe, Polaris, and then the nebula, and I'm not even going to try the last two, Zubin-el Ganubi and Zubin-el Shamali, which are in Libra. So most of these stars, most of the bright stars are used as navigation stars and alignment stars in Celestron and Skywatcher telescopes. So it's good to learn your bright stars and where to find them in the sky, because when you want to align your go-to telescope, you need to be able to pick those stars out. For Explore the Universe, there's not many deep sky objects in the spring sky. Now, of course, there's lots of deep sky objects in the spring sky, but most of them are galaxies, and they're a little too dim for the beginner Explore the Universe program. So they've only included a couple of 3 star clusters. So there's the Beehive cluster in Cancer, the Coma cluster in Coma Berenices, and there's one globular cluster, M5, which looks like it's in maybe Hydra or something like that. Anyway, so to find the Beehive, find Castor and Pollux and find Regulus and cast your binoculars about halfway between those, and you should find the Beehive. Similarly, you can find the Coma cluster a couple of different ways, but you look between Arcturus and Pollux, more or less, and you'll find the Coma cluster. It's a very nice wide cluster, one of the closer ones. And within that cluster, there's actually a double star, 17 Coma Berenices. And speaking of double stars, there's a number of double stars in the program that are indicated here. And again, these are all binocular doubles, so you should be able to find those with your binoculars. The Explore the Universe, you should be able to just use your eyes and binoculars to do all of it, although you can, if you like, use a small telescope, but you should be able to complete it all with just your natural vision and binoculars. And so it's a lot of fun. And the other thing is the double stars are easy. I wouldn't say they're easy, but you don't have to go to a dark sky site. So for us who are under lockdown and can't go to our observatory, this is a fun activity you can do from your yard in the city, if you're in a city. And as well, the lunar objects are things that you can do from home without violating any restrictions. So if you feel frustrated by not being able to get out and observe under a dark sky, try the lunar and double star and constellation objects to explore the universe. And that concludes my presentation. If there are any questions, I'd be happy to field them.
There aren't any at the moment. I'm just going to check the chat here for you. Nope, there's nothing there yet. Thanks again for a very comprehensive coverage of what we can expect in May.
Okay, no sweat.
I know we reference it. Your presentation's on our website.
Yes.
So just to refresh people's memory of what you said at the very beginning, it is on our RASC Halifax Center website so that you can go back and review Dave's presentation at any time of the month.
Yeah, Jerry tells me that he has a way of counting how many people look at it from month to month, and the number of views go up. Of course, he doesn't realize that I go in there and click on it about 25 times, you know. But what I was encouraged by is that the number of people clicking on it, or the number of views, is going up a bit, and that's nice to hear that people are going back and referring to it, and it's there for the whole month. So, okay, thank you very much.
Thanks so much, Dave. Next up is me. And going forward on this, it's news from the board for the past month, what's been happening, how it's exciting. As I said a moment ago, you can certainly go to our website. You can find us at halifax.rasc.ca. If you have any questions that you need to ask, you'll certainly reach me at our email for the center at president@halifax.rasc.ca. The bad news is our observatory is closed until further notice. This past Tuesday, our board met, and given the circumstances that we knew as of Tuesday, and realizing that it was probably going to get worse, we decided for everyone's safety, it was best to close the observatory down. And given the progress of the past week, we realized it was a wise decision. This is noted on our website, and as soon as some of the restrictions are eased, we will certainly change our position. But for now, SCO is closed. Even though that door appears open, it's closed. So we have a central star this month. Jason Dame came across this because one of our members made us aware of it. There's a magazine or a website called Astro Backyard, in which they feature equipment that people use out of their backyards from all over the world. There's articles in the past from the UK, Canada, the US, South Africa, and a few other weird and wonderful places around the world. And it shows their equipment set up in their backyard and some of the photos they've been taken. Well, on the April 26th edition, Jason Dane was the backyard of the week. So congratulations, Jason, on that one. And you can see some of the photos that were featured in the article there. Thanks to the efforts of John McPhee and Lisa Ann Fanning, we have a next edition of our Nova Notes, volume 52, number 2. Please go onto our website and read it. It is a phenomenal issue this time out. If you have any submissions that you'd like to give to John and Lisa for the upcoming, this is May-June edition, have your submissions to them by June 21st for inclusion, please. So go to this edition. Like I said, there are lots of really interesting articles in there that will certainly intrigue members of all various expertise. I mentioned in the presentation that I did at the very front, when I showed you all the benefits, all the magazines and our books and whatnot that you received as a member, but I didn't tell you how to join. This is how you join. You can join online. You simply go to our website, About Us, on our website, and you see a column there about becoming a member. You can see the word join in blue. If you click on that, it'll take you to the RASC website, and you can join from that point. Keeping in mind that when you join, you are a member of RASC. the national organization, but don't forget to affiliate yourself with the Halifax Center when you're joining. But if you're old school and you prefer paper and submitting a check to the organization, well, then you click on that little word form, and that can be, it'll take you to a PDF of the form, and you print it off, fill it out, mail it in, and away we go.
Can I just jump in for a second?
Sure.
This weekend is not ideal for joining online because there's a major transformation going on of the national website.
Good point, Chris. Thank you. Yes, National is undergoing a change, complete change in database systems. So yes, so you might want to wait until later in the week, next week to do this. Make sure all the glitches from their end or some of them are worked out. It is recognized, however, during the time of the pandemic that because of lost jobs or reduced number of hours that people are working, that they may have financial challenges in paying their membership. If that's the case, contact Adela Ziffi at mempub@rasc.ca, explain the situation, and hopefully they can assist. There was a large sum of money that RASC has set aside to assist members who can't afford the membership fees on an annual basis. So don't forget about that. Now, that's from National. Now, from our own center, we certainly have Halifax perks. There's the email discussion group that you can join. And again, you have access to the St. Croix Observatory. There are, you have to acquire a key to our observatory. For now, you have to be a member for at least 1 year and then have to contact our observatory manager, John Ledard, and request a key for the site. Heads up for our upcoming meetings. Our next month's speaker is Leslie Sage. He's Nature Magazine's astronomy editor. And as is noted below that, our star party, which was slated for August 6th to 8th, the new moon being the 8th, is canceled as an on-site event. It wasn't an easy decision to make, but the provincial park, Smiley's Provincial Park, sort of made the decision for us, given the group campsite that we normally use is not available to us in 2021. However, the board is looking into perhaps another way that we could celebrate a star party of sorts, although we do recognize that with the new moon on the 8th, it will not be held on the weekend because we don't want to upset our observers in our center who are keen on getting out that weekend to do some observing. In September, we have Dave Hoskin, who's going to be addressing the comet Neowise. And keep in mind that because, although our members are usually held the first Saturday, because the first Saturday is Labor Day, our meeting is the following weekend. October 2nd and 6th, we're working on some exciting talks for those 2 months. We can't announce them just yet. And then on December 4th at our AGM, Phil Groff has agreed to address our center that particular meeting. International Astronomy Day later this month, May 15. There are several international co-sponsors for this particular event. Our center won't be organizing any special event related to this Astronomy Day. However, as you note here, the Royal Astronomical Society of Canada is an international co-sponsor. And I am aware of a few centers already who have organized for this. In the coming days, we will be putting the links to their programs that they're offering on our website so that you can go on there, and certainly go onto the RASC site as well at rasc.ca. And I'm sure they will have some links as well to events they were hosting. You've heard Dave mention the moon at noon. It is every Thursday, or 1 o'clock, Eastern. And yes, out here it's, it's 12 Eastern. My apologies. It's 1 Atlantic. So for those of us in Nova Scotia, it's 1 p.m. Ontario time is 12 noon. You'll see the 2 books that people can purchase to record their observations for the purposes of the Explore the Moon. The blue copy is for those with the telescope, and the red with those who are using binoculars. Jenna Hines, John Reed, and Samantha Jewett are the 3 hosts. And as Dave said, he's the person in the background, although he was up front this past Thursday. So join them. It's every Thursday from now until June 17. The Insider's Guide to the Galaxy is certainly continuing. Chris Vaughn is the host with Jenna Hines as well. And it's every second Tuesday. And it's 3:30 p.m. Eastern. His next session is May 11. So keep that in mind. And to search for them, it's the moon. It's rasc.ca/moon at noon. Insider's Guide is rasc.ca/insider's guide. The GA, it's virtual, which we have known. The keynote speaker is Emily Calandrelli, and she apparently is the host and co-executive producer of Emily's Wonderful Lab. And apparently there were some kids that are on the program with her, and the youth scientists. So it's be interested to see what she has to say. Aaron Persad is the space science researcher at MIT. Kate Russo is an astrophysicist. Katie Mack is the Canadian Space Policy Advisor, and Kate Howells is an eclipse chaser. So that'll be quite exciting. You do have to purchase tickets to attend this assembly. If you're a youth member, in other words, someone under the age of 25, you get a really good deal at $10 to be able to attend all the sessions. Members, if you're a RASC member, $15 to attend all the sessions, and $20 for non-members. And if you only want the keynote, it too is $20. So keep that in mind. For us in Nova Scotia, one of the phrases that came from our 2 fellows that always does our press releases, or press conferences rather, our premier and our chief medical officer, the phrase they use is roar back. At the latest press conference yesterday afternoon at 3 p.m., Dr. Strang said, when asked, what should we take away from all these messages that we're getting from you? He said, take it seriously. And our premier said, stay home. So roar back at the virus. Everyone everywhere do what they're told. And to everyone in attendance, all I can say is stay safe, stay healthy, and don't forget to look up. You can still do that despite having to stay home. So, any questions? Okay, from the silence, I'll gather that the answer is no, there aren't any questions. So for those of you that would like to stay, please stay online, and Jerry and I will work furiously to upgrade you from attendee to panelist, and that way we can see each other. We certainly invite our guests to stay with us, our guest panelists as well. And it's an informal chat, so we can just sit around and talk about our experiences and whatnot. So thank you, everyone. And at this point, the recording stops.